All right, I want to look at a couple of examples that we saw in the last video, but do them algebraically here. We were looking at a circle, x equals cos t, y equals sine t, and then I said, what if we multiply that by 2? Well, we saw that it turned it into it looked like an ellipse. Well, I can see that it's an ellipse in the following way. By eliminating the parameter, I'm going to square both sides here. Actually, I'm not going to square both sides yet. I'm going to say x equals cos t. Here, I'm going to divide both sides by 2. So y over 2 equals sine t. Now I'm going to square both sides of each equation. So this is x squared equals cos squared t. This is y over 2, the whole thing squared. That's an arrow saying this turns into that, equals sine squared t. When I add the left-hand sides, I've got x squared plus y over 2 squared. When I add the right-hand side, that's a cosine squared, I've got cosine squared t plus sine squared t. So I solved this one for cosine, I solved this one for sine. Then I squared both sides, so I've got cosine squared, and I've got sine squared. Add those up. This is going to be sine squared t. This side is going to be 1. So I've got x squared plus y squared over 4 equals 1. And that looks to me like the equation of an ellipse that I saw in a pre-calc 1 class, where you go back and forth 1 in the x direction, you go back and forth 2 in the y direction, centers at the origin, and you're dealing with this ellipse. Right? We took our unit circle and we stretched it by a factor of 2 in the y direction, and we get this ellipse. Okay. Some other things that we noticed. What did I do next? I think I multiplied the x coordinate by 7, right? So I've got x equals 7 cos t and y equals 2 sine t, right? Well, if I do the same kind of thing, divide this one by 7, x over 7 equals cosine t, divide this one by 2, y over 2 equals sine t, and then square both sides of each equation. So this is x squared over 49 equals cosine squared t. This is y squared over 4 equals sine squared t. And then add left sides and right sides. So the two left sides add up to x squared over 49 plus y squared over 4 equals, add the right sides, cosine squared t plus sine squared t is 1. Right? And there you go. There's an ellipse that's stretched by a factor of 7 in the x direction and 2 in the y direction, just as we saw. One of the things we did next is say, well, what if we wanted to go around in the other direction? And I noticed that rather than the y coordinate, rather than starting at 0 and going up, right? We were looking at this ellipse here. I was saying rather than starting at 0 and going up, let's take the y coordinate and start at 0 and go down. So that should be a negative. So then we switch to, hey, how about x equals 7 cos t and y equals negative 2 sine t. Well, the process to eliminate the parameter is still the same, and the squaring is going to eliminate that. Actually, I could do the squaring first if I wanted to, because if I square it at this point, this is x squared equals 49 cos squared t, and y squared equals, the negative times negative becomes positive, so that's just a 4 sine squared t. Then divide, so x squared divided by 49 plus y squared divided by 4, y squared divided by 4 equals cosine squared plus sine squared is 1. Right? So the minus sign didn't make any difference from the point of view of once you square it, you're still going to be describing the same ellipse. It certainly does make a difference of whether you're traveling around the ellipse in a clockwise fashion or a counterclockwise fashion. I think I said those backwards. That's counterclockwise and this is clockwise. Okay, another thing I did was at one point I swapped the sine and the cosine around. So I had something like this. I had x equals 7 sine t and y equals 2 cos t. Well, it's still the same ellipse, because if I divide both sides by 7 here, x over 7 equals sine t, divide both sides by 2, y over 2 equals cos t. If I square the first one, square the second one, add them, x squared over 49 plus y squared over 4. Now, rather than having cosine squared t plus sine squared t, I've got sine squared t plus cosine squared t, which is still 1. Right? Addition's commutative. Doesn't matter if you add them cosine squared plus sine squared or sine squared plus cosine squared, you still get 1. So it's just by switching the sine and the cosine, we're changing it from, rather than starting here and going around at a time 0, when I think start, I think at time 0, I start here and go around. Instead, I'm starting up here for this one, because the x-coordinate starts at 0 at time 0, and the y-coordinate starts at 2 at time 0. So you're up here. Right? And this one happens then to be going that way, because the x starts at 0 and gets positive, so it starts here and goes bigger. Okay. One last thing that we did in that last video was we shifted some things. I ended up with something that looked like x equals, did I shift it 1 in the x direction, plus 7 cosine t, and y equals, I think I shifted it down 3 in the y direction, y plus 2 sine t. Now, to eliminate the parameter on this and see this as an equation in x and y where we're going to recognize that, oh yeah, that's an ellipse with a certain center and, you know, stretch so much in whichever direction, solving for t is really not the way to go. I mean, I could do it. I could subtract 1, divide by 7, take the inverse cosine, then you'd have t, and you'd plug it in. So you'd have y equals -3 plus 2 times the sine of the inverse cosine of something. It's like, what the heck is that? Well, we have the techniques of figuring out what the sine of the inverse cosine is, but I think it's just easier if we avoid that and say, wait, sines and cosines are going to go together when we square them. So let's solve for cosine t from this first one. So subtract 1, and then divide by 7. That's cosine t. Add 3, and then divide by 2. That's sine t. So now if I take this and square it, x minus 1 over 7 squared, and I add to that this one squared, y plus 3 over 2 squared. That's the same thing as taking this one squared plus that one squared. Right? Square the first equation, square the second equation, add the left-hand sides, add the right-hand sides. And the reason we did that is because this will eliminate the parameter. It looks like a sine of 2t. This is a sine squared t. Sine squared t plus cosine squared t is equal to 1. So I'm left with the equation x minus 1 quantity squared over 49 plus y plus 3 squared over 4 equals 1. And that, from my training in pre-calc 1, I know is an ellipse that's got a center at 1, -3, and it goes back and forth 7 in the x direction. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And up and down 2 in the y direction. Right? And so we've got this ellipse. Whoa, didn't quite go long enough. There we go. So you've got that ellipse. But I really like the fact that in parametric equations, it's really pretty easy to come up with the equation of a ellipse. Because if you know where the center is, then you know what these two numbers are. And if you know how much stretch there is in the x direction, you know the amplitude of what you got to do in the x direction. And if you know what the stretch in the y direction is, that is stretch from the unit circle, so this is amplitude 2 in the y direction, then I can get that, that equation pretty quickly. In fact, let's do one example. Let's suppose I want an ellipse that is centered here at 3, 4. It just barely touches the y-axis here, and it let's just make it really skinny here. So let's just do this. 1, 2, 3, 4. Okay. X equals, y equals. Well, the x is going to be centered at 4. This is 4 right here. This is 3. The x is going to get as big as 8 and as low as 0. So the x is centered at 4, so this is 4 plus something. The y is centered at 3, down as low as 2, up as low as 5. So this is 3 plus something. The sine, let me see. If I use cosine for x, I have to have amplitude 4, because I need to get all the way up to 8. I need to get all the way down to 0. So if I do 4 cos t, then that's going to start me off over here, because at time 0, cosine of 0 is 1, so 4 plus 4 is 8. That's as big as possible. So the y value is going to start off in its middle. It's going to start off at 3 and then either go positive or go negative. Either way you can do it. But it's amplitude 1 here, it looks like. And let's just say it goes up. Let's just say sine t. Okay. There's the parametric equations for that ellipse. Okay. All right, there you go.